Hello friends, welcome to our channel. Today our chapter is quadratic equation. Now you know that what is quadratic equation? That polynomial which have the degree 2, that is called the quadratic equation. यानी degree 2 होनी चाहिए, उसको quadratic बोलते हो. In general आप equation बोलते हो ax square plus bx plus c equal to 0 अगर है, that is the quadratic equation. Now you know that the highest degree, what is the highest degree of polynomial is the number of roots of that polynomial. Means I want to say that quadratic equation have highest 2 degree. That means quadratic equation have 2 roots. Now two methods we will discuss here. One method is the Sridharacharya method, which is minus b plus minus under root of b square minus 4ac by 2a, and one is the direct method in which you split the mid term and factorize the term. Now you say that seen that the answer is same in both the cases. Now the main point here is the nature of roots of the quadratic equation. If we have a quadratic equation, you will find the nature of roots. How will you find out this? In general, the equation of quadratic equation is ax square plus bx plus c equal to 0. Then you can see that it's have two roots from the Sridharacharya method. One is plus root and second is minus root. Now you will find the what is the discriminant here. Discriminant play a very important crucial role in this. Discriminant is b square minus 4ac. You can check the discriminant for the nature of roots. In first case, if you have discriminant greater than 0, then your roots are the real and different root. In second case, if your discriminant is 0, then your equation is real and your roots are equal. In third cases, if you have discriminant less than 0, in that case only you have imaginary and different roots. In fourth case, you can see that if your discriminant is greater than 0 and is a perfect square also, then your roots are rational and different. Now let's move to the second part of this. Now you have equation for the nature of roots 2x square minus 9x plus 7 equal to 0. You will find the nature of roots here from the discriminant. Discriminant here is the b square minus 4ac. Now you put the values from this equation by equating this equation by ax square plus bx plus c equal to 0. General quadratic equation. Here b square, b means the coefficient of x. 4ac, a is the coefficient of x square and c is the constant term. Now you will compare this term and put this value in discriminant. You will find that discriminant is 25 here, which is greater than 0. If discriminant is greater than 0, also 25 is a perfect square, then your roots are the natural and different. In second equation, if your discriminant is greater than 0 but not a perfect square, in this case your roots are real and different or irrational roots. By the option you will check it's given real or irrational. Second equation, if your discriminant is less than 0, then your roots are the imaginary and different. We have also the direct result for the roots of an equation. If we have every n degree equation has n roots, highest degree equation has highest. If quadratic equation have highest degrees 2, then quadratic equation have 2 roots. If you have n degree equation, then you have n roots. If you have a odd degree equation, then you have at least one real root and coefficient of highest term is positive, then the constant term have the opposite sign of the highest degree term. Third direct result here, if the coefficient of highest degree term is even degree equation and positive, constant term is negative, then at least two real roots, one is positive and one is negative. The next result is if there is only one change in sign in an equation, it has only one positive root. If all terms are positive and odd degree term, then your all roots are imaginary. That is the direct result we put in this equation. We also have the roots in pairs. If we have a quadratic equation and your constant are given rational here, then your roots should be in pairs. If one root is alpha plus iota beta, the second root will be automatically alpha minus iota beta. If one root is alpha plus root beta, second root will be alpha minus under root beta. Meaning roots are in pairs. The next term is relationship between roots and coefficient. We have a quadratic equation given. Let's see alpha and beta are the roots of this equation. Because we have quadratic equation, we have two roots of the equation. Let us assume these roots are alpha and beta. Then two important point here is sum of roots, that is alpha plus beta, which is equal to minus b by a. Minus b means the coefficient of x minus coefficient of x divided by coefficient of x square. The second is the product of root, that is alpha beta, that is the constant term coefficient divided by the highest term, yani x square coefficient. We put this in equation. We all find automatically the given equation, quadratic equation, which is given. Next are the symmetric expression of the roots. If you have given in equation a quadratic equation and the alpha square plus beta square, then you have to put this equation, you convert this equation in sum of roots and product of roots by arranging them. Let's see alpha square plus beta square. You know that alpha plus beta whole square is equal to alpha square plus beta square minus plus 2 alpha beta, but you have to find out the value of alpha square plus beta square. Then put this in right side and you will find that alpha plus beta square minus 2 alpha beta is your given value, and you can easily put this value of sum of roots and product of roots and find the solution. Next is reverse of alpha and beta. You can simply see that if you take LCM of this, you can convert this equation in sum of root and product of roots. Also in that case you can put these values in sum of root and product of roots. Left side value is given in your equation and you can change or convert this equation in sum of root and product of roots. Learn or easily way to solve it. Next you can find that the next is roots under particular condition. You have given some particular condition in equation. If you find this condition, and you can find the nature of roots automatically without solving the question. First condition is here that if the coefficient sum, all the coefficients sum a plus b plus c equal to 0, then your roots are automatically two values. One root is one compulsory and second root is c by a. If your midterm coefficient b equal to 0, then your roots are the negative of each other. If you have constant term equal to 0, then one root is automatically equal to 0. If you have the coefficient of x and constant term coefficient equal to 0, then your both roots are 0 from this equation. If your a coefficient is equal to c coefficient but in opposite signs, then your roots are the reciprocal of each other. If your discriminant is greater than equal to 0 and ABC same sign, then real roots होंगे and both are the negative. If discriminant greater than 0 है, B have opposite sign but AC have same sign, then real roots but both are positive. If the B is equal to 0 and AC is the same sign, then you have the imaginary conjugate roots. Let's put the example 3x square minus 5x plus 3 equal to 0. You can see that A coefficient equal to C coefficient here, A equal to C. In that case, you can find the nature of roots. Roots are the reciprocal of each other from the equation. Next question is 3x square minus 2x minus 1. You can find here the sum of a plus b plus c equal to 0. Then your roots are 1 and c by a. Next, if you have the equation x square minus 5x minus c, you can see that a is positive but c is negative here. Then your roots are the real and of opposite sign. Next is the condition of the common roots. If you have the two quadratic equation, then if both roots are common, then your coefficient ratio is equal. If your one root is common, then you can put the 2 3 1 2 method, that is x square by cross product of this one, and last term is minus 1. Now check at the p by q on the basis of the quadratic equation. First question here is which of the following is quadratic equation. You can easily solve the each option. You can check each option for the power, highest power. If you have a polynomial which has highest power 2, then this is your answer. This is the quadratic equation. In this option you can easily check that fourth option has the highest power 2, yani degree of polynomial is 2, then it is a quadratic equation. In second question, you can find which of the following equation has 2 as a root. If 2 is the root, if some value is root of that equation, then if we have put these values in equation, it satisfies the equation, means making the equation equate to 0. If we then you can easily put the value of x here is 2. If 2 is satisfied that equation, that is your answer. Next is question is if 1 by 2 is the equation of this one, value of k is क्या होगी. If 1 by 2 is the root of equation, then it is satisfy this equation, equate to 0, and you can find the value of k easily. Next question, what is the value of k for the quadratic equation have equal roots. Equal roots in cases if we have the discriminant is equal to 0, discriminant equate to 0, and k value is easily find out here. The next question is the most important question. Which constant must be added or subtracted to solve these question by the method of completing the square. Then in case x coefficient denominator square is added and subtracted from this equation, and you can find that 1 by 64 is your right answer. Next equation, the quadratic equation has which roots. You can easily check the discriminant. Here discriminant is less than 0, then its roots are imaginary, means no real roots. Next question is what is the following equation has two distinct real roots. Distinct real roots means discriminant greater than 0. You can find from each options which equation has, which polynomial has the discriminant greater than 0, which is your right answer. Next is which of the following equation has no real roots. no real roots mean discriminant is less than 0. You can check all these options for the discriminant less than 0, and what gives the value discriminant less than 0 is your right answer. If you have this equation and you can find from this, if all terms are positive, then you have no real roots from the nature of roots. Next, if you have alpha beta is the given the roots of this equation, when find out the 1 by alpha plus 1 by beta, then in the particular case you can change in it from sum of root and product of root. You simply take LCM of this, then alpha plus beta, and alpha beta is your simplified term, that is the sum of roots minus b by a, and you can find the value of alpha beta also, that is the product of roots, that is c by a. Easily put the values from the quadratic equation and find the solution. Next question here, if you have the roots equation is given, what is the value of q? Roots is given here is real means real and equal, means discriminant equal to 0. Put the discriminant equal to 0 and find the variables value. If the product of roots is given, product of root matlab c by a is given equal to 2, then c here is the coefficient of constant term and a is the coefficient of x square. Put the value for the solution. If the roots are alpha and beta, then roots of this equation is reverse of this equation, that is 1 by alpha and 1 by beta. You can easily find from the equations. If alpha beta positive integers, in positive integers case, one root is p minus root q, then second root is automatically the negative of this root p plus root q. Pairs, roots are in pairs. Put the values for sum of roots and product of roots and find the solution. If alpha beta are given the roots of this equation, what is the value of this equation? Simplified for the sum of roots and product of roots, and put the values from this quadratic equation and find the solution. All the questions of the same type you can easily find from the all the questions with solution with hint are given as a PDF to our Telegram channel. Join our Telegram channel for more details.